Now, to plot a curve of this nature that satisfies this equation, we adopt a very nice method. So what we do here is we try to think about this problem or this equation as a as a curve in the Cartesian plane, right? So that means what we do is we represent theta with x and r with y. So what we have here is that y is equal to 1 plus sin x, right? So now we plot this one in the Cartesian system, right? So in the Cartesian system, if we plot the two curves in the Cartesian system, now remember this should originally be drawn in the polar coordinate system, right? So that has nothing to do with this one, but still we are going to draw this equation in the Cartesian system, and then I will explain how we are going to relate the two curves, right? So now first let's focus on drawing this curve y equals 1 plus sin x in the Cartesian coordinate system. Now you should be able to draw these curves without using any graphing calculators, right? Because there's a very easy way. Now to obtain the curve of this one, what we can do is we can first draw the curve for y equals sin x, right? So the curve for y equals sin x will be like this, right? So it will go like this, where this value will be pi over 2 and this value will be pi, and likewise it will take this oscillating shape, right? And what will happen if we add 1 to this right hand side? Now for example, if it is just sin x, what will be the value of y when x is equal to 0? Then it will be y equals sin 0, and that is equal to 0, right? Sin 0, and that is equal to 0. But if it is sin x plus 1, what will be the value at the same point? So now this point is plotted in here, right? When x is equal to 0, y is equal to 0. That is the 0, 0 point. Now remember we are in the Cartesian system, right? Okay. Now if we have this equation y equals sin x plus 1, then at x equals 0 we have y equals 1 plus sin 0. So here we get 1. So simply what we have is the same values for this case shifted with a 1, right? So it's like now for x equals 0, the value of y is 1. So this is what we have now. That means the same situation will happen for each and every point. Same situation in the sense all these points will be pushed upwards by 1 unit. So all these points will be pushed like this while maintaining its shape. It will be pushed by 1 unit. Now this is -1, so when it is pushed by 1 unit you will get 0. Therefore for the y equals sin x plus 1 curve, you will obtain the exact same shape but shifted with 1 unit, right? That means the curve of y equals 1 plus sin x will take this format, right? It will go like this, right? So this is the 0, 0 point, and here you have pi by 2, and here you have 2, here you have 1, right? And at this point again you have pi, because sine pi is 0. When you have 1 added to that, you will get 1, right? And this point will be 3 pi by 2, which was originally a negative 1, right? Okay, now we have obtained the curve of y equals 1 plus sin x, and we have plotted that curve in the xy plane, which is the Cartesian system. Now, as we used this relationship, we can even represent the same values like this, right? Now still this is in the Cartesian system, right? Because in the Cartesian system, like, we have these perpendicular lines only on the Cartesian system. Now we have to draw it in the polar coordinate system, and in the universe of polar coordinates we have only this thing, right? The pole and this axis, right? Then we should find the suitable r values for each and every corresponding thetas. That can be done simply by looking at this curve. Remember, in the previous question we computed the values of r against each and every value of theta. I think I have erased that problem. No, I haven't. See, here we compute the values of r against each and every theta values manually. But here we are going to use this diagram to obtain the correct or the appropriate relationship between r and theta, right? So if it is plotted in the Cartesian system, the relationship will look like this, right? But when it comes to the polar system, it is different, right? So the main thing that you should identify or to understand is that these are two different types of environments, right? Okay. Now, starting at 0, if we look for the initial point at 0, when theta is equal to 0, r should be equal to 1. Now this is in the Cartesian plane, and when it comes to the polar coordinates, then it says when theta equals to 0, r should be equal to 1. That means when theta equals to 0 means this angle is 0. That means this line, because we are measuring the angles with respect to this line, right? So when theta equals to 0, r should be equal to 1. So we are starting at this point. And then you can see that when theta increases up to 90 degrees, right, or 90 pi by 2 radians, then the value of r will increase up to 2, right? So that's a special case, right? Now if we just draw a dotted line, now this is not the y-axis of Cartesian plane. I am drawing this dotted line because then it will be easy to understand the 90-degree angle. That's the only reason for drawing this dotted line. Otherwise it does not exist, right? Okay, so now here it says when theta increases up to 90, that means theta is measured with respect to this term, this axis, and theta increasing means this will move towards this direction, and theta 90 means it should coincide with this dotted line. Then r should gradually increase up to 2. That means each and every point in here will have a different value of r. The r at here, the starting point is 1, but for all these points it will gradually increase. None of these points will be equal to 1, right? The r value of all these points will be greater than 1, and at this point it will reach 2. So the polar coordinate at this point will be 2, pi by 2, right? That means this point. Okay, then what happens? When the angle is increased from pi by 2 to 3 pi by 2, no, let's take this point. When angle is increased from pi by 2 to pi, the value of the radius should decrease from 2 to 1. That means the angle is increasing from pi by 2 to pi. So it starts at this angle, which is pi by 2, and then it keeps on increasing because we are measuring the angle starting from this axis, right? So when it goes in the anti-clockwise direction, it increases, right? So it increases up until pi, right? So this whole angle will become pi, and when that angle increases from pi by 2 to pi, the radius should decrease from 2 to 1. See here, that's the nature of these values, right? So the radius r value will decrease from 2 to 1. So here the radius will decrease from 2 to 1, right? So here you will get -1. Now actually there is no point of marking -1 here because you really don't have an axis like this. Okay, so it is incorrect to mark -1 in here because we are not in the Cartesian system, right? So the actual coordinate of this one is 1 and pi because we are in the polar coordinate system, right? So the theta value here is pi and the radius is equal to 1, and the theta value here is pi by 2 and the radius is equal to 2. So when theta increases from pi by 2 to pi, the radius should decrease there. Now my diagram might not reflect the exact pattern because now sometimes you might think that the distance between these 2 points is equal to the distance between these 2 points, which is not. Okay, here the radius is equal to 2 and the radius should gradually decrease until 1, right? So this is not a half circle, right? Because if it was a half circle, the radius should be the same, right, everywhere, right? But here the starting radius is something and here the radius is something else, and then it comes back to the same starting point, right? So this is not a half circle, right? That's important. Not a half circle. right? Okay, now the remaining part. From pi to 3 pi by 2, that means from pi to 3 pi by 2, when it goes from here. Now that angle should actually starts at this point when it increases like this, and until this point we have already drawn the curve. So now we are left with completing the values for from pi towards 2 pi, right? So what will happen when you increase the angle from pi to 3 pi by 4 at this point? Then the radius should decrease from 1 to 0, right? So the radius, we are starting at this point, and then it will have a decreasing radius until 0, right? So now so far what we have drawn is something like this. You have a curve, in this axis you have not an axis. Now in that direction you have a higher value, right? Here you have 1, here you have 2, and then for this portion, that means when theta increase from pi to 3 pi by 2, right, the values will have a decreasing radius starting at 1. So this will have a radius of 1, an angle pi, and for each and every point in here, will have a decreasing radius, right? So the point in here will take this theta value, which is greater than pi and less than 3 pi by 2, because 3 pi by 2 will lie on this vertical line, right? Now all these lines are dotted lines because they actually do not exist when it comes to the polar coordinate system, right? And then from 3 pi by 2 to 2 pi, the radius will again increase from 0 to 1. That means it completes this one. So putting all those things together, we will have a curve like this. It goes like this, and it goes like this, and then you will form something like this, right? Well, actually now it is not correct. Sorry. Now here it is not correct to draw the axis like this, because actually since we are drawing it in the polar coordinate form, what we have is this one. So everything else was written or drawn to identify the angles easily, right? So actually what we have is something like this, right? And you will, if you need to identify the angles properly, you can draw this as a dotted line, and also this diagram should be symmetric like this. Okay, see, now without drawing these dotted lines, it is very difficult to draw a nice curve, right? That's the only reason for drawing these 3 lines. Okay, otherwise they do not exist, as it was in the Cartesian system. They do exist, right? The negative x values and all these y values will exist in the Cartesian system, but here it doesn't make any sense because we are in the polar coordinate system. So anyway, the shape of the curve will take this nature, and it was drawn with respect to this curve, which was obtained by considering the Cartesian nature of the given terms theta and r. We first drew the relationship between theta and r in the Cartesian system and observed how radius will vary according to the values of theta, and then we plot it in the polar coordinate system.